Okay, function notation. When a function f is defined with a rule or an equation using x and y for the independent and dependent variables, we say y is a function of x to emphasize that y depends on x. So we use this notation right here. Y equals f of x, okay, called function notation. So to express this and read f of x as f of x, the letter f is the name given to this function. For example, if y is equal to 9x minus 5, then we're going to replace y with f of x. So the function of x is equal to 9x minus 5. Okay, note that f of x is just another name for the dependent variable y. For example, if y equals f of x equals 9x minus 5 and x equals 2, then we find y, or f of 2, by replacing x with 2 right here. So x is equal to 2. So plug in x equals to 2. 9 times 2 minus 5 equals 13. Okay? The statement, if x equals 2, then y equals 13, represents the ordered pair 2, 13. Okay? And is abbreviated with the function notation as this right here. So f of 1, for example, the function evaluated at x equals 1 is going to be 9 times 1 minus 5, which is equal to 4. So we would say f of 1 is equal to 4, is what we would say. Okay? So basically, y equals 4 and x equals 1. So the ordered pair is 1, 4. That's how you would write that. So let's do some examples here. Okay, notice I have two functions. I have an f of x and a g of x. Okay, in example A, I'm going to use function f, negative x squared plus 5 times x minus 3. Okay, x is 2, so put a 2 in the parentheses. So I get negative 2 squared, okay, plus 10 minus 3. Okay, since the negative was outside the parentheses there, I'm going to do 2 squared separately from the negative. So 2 squared is 4, so negative 4 plus 10 minus 3. And then PEMDAS says adding and subtracting goes from left to right. So negative 4 plus 10, 6 minus 3, so the answer is 3 right there. Okay, let's look at the next one here. We have the function of f evaluated with the letter q. Okay, so the function of f is negative x squared, and I'm just going to use empty parentheses, plus 5 times x minus 3. Okay, so if x is equal to q, we're just going to put a q in there. Okay, so the result is going to be negative q squared plus 5q minus 3. That's it, right there. We don't know what q is. We're just evaluating. We're substituting it for x into the equation or the function. Okay, on this last example, notice this is the function of g. So we're going to use 2x plus 3. So 2 parentheses for x plus 3. Okay, to evaluate it, we're going to plug in a plus 1 where x is. Okay, so that's going to give us 2a plus 2 plus 3. And that simplifies to be 2a plus 5, and that would be the answer. Okay, notice back in the directions it said find and simplify each of the following. So if you have a variable that's being substituted in, you're not going to have an answer in the, like a number answer. You're just going to have an expression like we have on B and C here. Okay? Okay, we're still talking about function notation, but we're going to go ahead and look at it in a little bit different type problem. Okay, over here, for each function, find the function evaluated at 3. If x is equal to 3. All right, so on this one here, on A, we're going to do 3 times 3 minus 7. So that gives me 9 minus 7 equals 2. Okay, so that one, I got a 2 when I substituted x equals 3. All right, on this next one, B, I have a set of ordered pairs. Okay, so what I have to do is I have to look for x equals 3. Okay, so on this first one, x is negative 3, x is 0, and x is 3 right here. So what is f of 3 equal to? 1. And that's how you would answer that question. That's it right there. Okay? Let's go back over here to C. The domain represents all of your x's. Okay? So go through your domain and look for 3. Here it is. So what does f of 3 equal in this relation? It equals 5. Right here. X is equal to 3. Right here, they specifically told us to find when x equals 3. Okay, in this last example, you have a graph. So go to x, go to 3, and go up to your graph. And what is f of 3 equal to? 4. So f of 3 equals 4. Okay, now we're going to look at increasing and decreasing functions. Okay, so notice on this first example here, if you read your graph from the left to the right, as we move to the right, the y values are getting larger and larger, okay, on this graph. So we call that an increasing function. Okay? On this graph here, you still read it from left to right, but as we come along, notice that it's getting lower and lower. Okay, so that is a decreasing function. Okay, and on this last example, as you go from left to right, nothing changes. Okay, that same y value appears all the way across. So that's called a constant function. Okay, so when I give you a problem and ask you to analyze it, okay, let's look at it. We've got a swimming pool, the water level in a swimming pool. Okay, the x-axis is measuring hours. Okay, the y-axis is measuring gallons. All right, so to determine if it's increasing or decreasing, I want to know what's happening to the gallons of water as we move along the hours. Okay, does that make sense? So starting at 0 hours all the way to 25 hours, what's happening to the number of gallons? So what do you think is happening here in real life to the swimming pool? They're filling up the pool. Okay, so from 25 hours to 50 hours, right in that section, what's happening? So what did they probably do? They're done, right? Or they turned off the water, didn't they? Okay. And then from 50 hours to 75 hours, some of the water is coming out, isn't it? Right? And then after that, what does it show? So is the swimming pool empty? No. How many gallons does it have in it? 2,000. Okay. So in real life, what do you think could have happened right in this section right here? Maybe they overflowed the swimming pool, maybe, didn't they? And some of it had to come out. Okay? And that's how you evaluate increasing and decreasing. Okay? So if I was going to ask you to write this down, though. Let's talk about an interval that's increasing. Okay? From 0, actually that should be a bracket because it equals 0. From 0 to where is it increasing? So on the interval 0 to 25, it's increasing. Okay? Where is it constant? 25 to 50. And then where is it decreasing? Okay, it's decreasing from 50 to 75. Okay, and then after that, what is it doing? And then it's constant. How would I write this interval in this space here? 75 to infinity. And that has to have the parentheses since you cannot touch infinity. Okay, that's at the very end where it's constant again.